the presentation.
Okay. Okay. Well, good morning, the Netherlands, and selamat sore, Indonesia. Very sorry for the late technical issues, but I think um, we all are used to these technical issues. In this second day of Winter 2020, our team would like to present a session on modern ways of exploring geothermal resources in Indonesia and the Netherlands to boost the energy transition. In this session, we will have short pitches from geothermal experts from our partners in Universitas Indonesia, Instituut Technologie Bandung, Utrecht University, TNO, and the University of Twente. There will be 7 speakers, Professor Freek van der Meer, Dr. Chris Hecker, Dr. Suyantini, and Dr. Asep Saipullah, Dr. Yunus, and then we hope to wrap up in 15 minutes. I think we can go to the next slide. I'm not sure if Freek is here, but I can try to present his slide. So this community we are at the moment is began in 2013. We have a project called Geothermal Capacity Building Program Indonesia and the Netherlands. Professor Freek van der Meer is the GEOCAP project leader and a project manager from the University of Twente. So GeoCap started in 2013, and we will have officially end until 2021 and a bit the first half of 2022. Our project and knowledge institute. So we really collaborate with different types of organizations. If you can see there, the universities like TB, UI, UGM, Utrecht, ITC, and TU Delft at the beginning, and companies like TNO, DNVGL, IF Technology. We also work with INAGA. This is Association on Geothermal Energy companies in Indonesia, and we were collaborating through the Indonesian government, such as Bappenas and Ministry of Energy, ESDM, and of course supported by the Ministry of Foreign Affairs of the Netherlands. Next, Fred, please. Yeah, so during this last couple of years, we have done many activities in the Netherlands and Indonesia. We had 3 main components, education and training, with different types of activities in geothermal. We really work from the reconnaissance, explorations, and the technique, and we also touch upon the rules and regulations and policy at the end. We work in the high enthalpy geothermal and also the low and medium enthalpy geothermals. I think this is a short introduction on GeoCap. We can start with the first page. This and real-time needs. What are actually the pressing issues in geothermal energies and renewable energies? Techniques for explorations are required, and what need to be developed further, and what type of geothermal systems need to be explored. So hopefully at the end we can answer those questions. So the first one would be on remote sensing for geothermal exploration. Ibu Dini, Chris, and Asep, I give you the floor. Ibu Dini, I think you're muted.
Yeah,
yes.
Okay, thank you. It's a bit tricky. I cannot unmute myself. Okay, thank you, Ibu Tia. Yeah, I have to start as fast as possible. Okay, based on my experience for almost 25 years doing geothermal exploration and to some extent also mineral exploration, finally I come to the conclusion that a good study or literature study at the early stage of exploration will support the discovery of geothermal prospect and of course another prospect. Yeah. Therefore, literature study must be carried out in a detail, carefully, and interpreted with many possibilities related to the targeted resources. In our cases, it is geothermal system. We must assume that all available data is useful, including technical and non-technical data. Never underestimate the importance of data, even though it comes from local people or local knowledge. For example, if local people might know the location of thermal manifestation that has been buried by landslide, for example, yeah, or other information you can see or search from the newspaper, YouTube, someone's blog, or many other things. At this stage, remote sensing is one of the best tools, and I suggest we can utilize it and to use it, start with the cheap one or the free remote sensing data. This is become the focus of my talk. With public domain or free remote sensing data, we can make such detailed and informative image as shown in the left side of my slide here. This is the image from DEMNAS, where we can see the detailed morphology or the prospect area, and we can interpret the possible structural geology or volcanostratigraphy of this area, which are important for geothermal exploration. The application of remote sensing in geothermal exploration are numerous. And here in my slide, I wrote some of them on this slide. Yeah, it's such interpreting regional detail geology, interpreting faults or permeability, locating thermal anomaly, or for the future plan. Next, Butia. Yeah, in this slide, my colleague has helped me. Yeah, my colleague from ITB, Hendro Wibowo, MSc, has helped me to list public domain remote sensing data, which is often we use early before our exploration to the field. Yeah, so this is in the desk study. This is free and it can be downloaded directly from the link. For Indonesia, we have a special link. Yeah, there is a very useful data. There is DEMNAS, yeah, Digital Elevation Model Nasional. It is listed at the second from the bottom of the list. The resolution of DEMNAS is 8 meters, so it's very detailed, quite detailed actually, and quite good for interpreting geological structure, morphology, and delineating lithology. Next. In this slide, I show you some examples on how we can utilize remote sensing data, and we are quite surprised with the result actually. As you can see, I have at least 3 pairs of images as the result from 3 different image processing that can be used for geothermal exploration. Yeah. For example, number 1, it is NDVI, Normalized Different Vegetation Index. Actually, it is to search for vegetation stress that probably associated with ground thermal anomaly. The example of the image at the right side, shown at the right side, at the very top, it is the true color composite, yeah, at the left side. True color from the true color composite, we can see our area is cloud-free. So the NDVI anomaly is not related with the cloud. Yeah, the area of vegetation stress is shown in the right image as a red color area, which is overlain on top of prism. It is similar like them. Red color areas are mostly associated with bare ground of the crater or thermal area. But at the southwestern area, where the vegetation looks green and healthy, surprisingly, it is associated with low resistivity anomaly of empty data at the surface. Perhaps it tells us something, maybe the caprock or whatever. We don't know yet. Yeah. The image in the second layer, second processing, in the middle is it is mean temperature anomaly from several images and its standard deviation. It is from AG100 Aster Global Emissivity Dataset. It can be downloaded from USGS Explorer website under Aster Global Emissivity Datasets. In this example, we found that the standard deviation image in the middle shows two separate regions bordered by a black line. And surprisingly, the pattern is more or less associated with satellite gravity data at the right side, as well as ground gravity and empty survey, which I cannot show you at this time because it's confidential. But in general, it has strong correlation. And the last image at the bottom, it's a example on how we use band ratio to map clay on the surface, which is associated with the occurrence of thermal manifestation in the study area, shown as white circle. I also wrote some other application of remote sensing analysis, but because of limited time concern, I could not explain in the detail. After my presentation, I believe my colleague Chris and Asep will explain you more about remote sensing and in particular radar. Yeah. At last, I must say that at the early stage of exploration, we must optimize our data, including remote sensing, but don't overconfidence with only one data. For remote sensing, a ground check is a must-do program, as well as cross-check with other literature data or supporting data. I think that's all my presentation. Thank you very much. I return to Butia.
Yes, thank you. I think we can already start with the next one.
Yeah, so
Chris?
Buninik has given us a nice overview of different remote sensing data sets and techniques. And what we do when we do proximal sensing is we use those same techniques, but we actually take them to the laboratory. So we have it here grouped with as proximal remote sensing. And on the right side, you see an example of a study that we're doing right now with the PhD student from Indonesia. And she's analyzing drill cuttings from geothermals with these techniques. So what we do is we take cuttings from different depths of the system and we scan them with infrared imaging. And at the bottom right, you see an example of that. You have cuttings from 3 different depths. And the left one is showing a lot of clay from the kaolinite groups, a special clay group that also shows acidic environments. The middle one is dominated at a further down, is dominated by clays from the smectite group. And the one on the right side in the green colors is dominated by minerals from the chlorite-illite group. So these index minerals tell us something about the temperature and pressure conditions in the system. And if you look at the schematics at the bottom left of your screen, you see that when we drill through these different areas, we come across these different alteration zones. We detect different minerals. And by analyzing the drill cuttings, we can get a quantitative idea of which minerals are in there, at what depth. And we get an improved understanding of the system and hopefully save money by knowing where we are in the system and putting the next well exactly in the spot where we have the best conditions to extract the geothermal resource. Next slide, please. Another application that Buninik talked about is thermal remote sensing, and sometimes you can use satellite data, free satellite data for it. But if you want to have a more detailed study, then you might want to go to an airborne campaign. So what I show here is an example of an airborne thermal infrared campaign, which we did over Flores Island. And at the bottom left, you see one of those results from an MSc student of ours, where the lighter colors show geothermal hotspots, and the darker colors are the forests surrounding it. And not only do you see areas that are warmer, but you also see how they align. And the airborne data has a big advantage of its sub-meter resolution. So it's much finer and you see much more details. On the right side, you a typical boiling which is an anomaly that we were not aware of before, and that one also shows in the airborne data, while in the satellite data we would have missed that one. Next slide, please. Also important if you want to do a detailed study and the free DEMs that you have do not suffice. If you want a bit more detail, then you can do airborne lidar mapping. On the bottom left, you see an example of a result. You see how detailed the topography can be scanned with this. And it helps tremendously with structural mapping, but not only that. Another application is also that you can plan your infrastructure. For example, you can calculate volumes for your well pads. You can calculate how much volume do you need to bring in and where do you bring it in from, so you can really plan your infrastructure well with this technique. On the right side, you see a new application of LiDAR that we're currently working on, also with an Indonesian PhD student. And he's looking at how the LiDAR signal, the laser pulse, is actually reflected and how much intensity we get back. And on the very right side, you see a test series from top to bottom, different rocks with different alteration intensity. And you see as the rocks alter, so that's a term for changing the composition to a more clay composition. As they alter, the reflectance, the intensity gets higher. So the laser beam is reflected with more strongly. And we want to look at this application in the future if we can detect altered areas in a geothermal system based not on the topography of the LiDAR signal, but based on the intensity of the reflected LiDAR signal. So that's also a new application that we're currently looking into to get quantitative information about the environment. Next slide, and then we move on to Asep.
Okay, maybe I will continue from Bunik and Chris. So now I'm talking about the SAR remote sensing, as I mentioned by Bunik. So the synthetic aperture radar, or SAR remote sensing, is an active remote sensing technology utilized the wavelength in the range 1 millimeter to 1 meter. And the SAR sensor could operate in any seasons, regardless time acquisitions in producing cloud-free images. The SAR backscattering image consists of the reflectivity properties of the object, such as the electric constant and moisture. Accordingly, we could identify the wet and dry ground as well as alteration clays in the geothermal field. An advantage of the SAR system is a deeper penetration than optic system when the surface is dry. Therefore, obtaining the data in dry seasons is crucial to identify buried near surface targets such as paleochannels or rivers. Next slide, bro. Yeah. And then, as consequence of surface to the north and descending orbit when the satellite moves to the south. Accordingly, the system is possible to extract the lineament-related structures, although at low topographic contrast. The bottom left figure is example of lineaments extracted from the two ALOS pulsar intensity image of ascending in red lines and descending in blue lines using modified segment tracing algorithm. And the final lineament map by merging the lineaments from the two orbits modes as presented by blue lines in the bottom middle figure. Further analysis could be performed to identify the surface fractures permeability based on the density of lineament frequency as presented by the top right figure. In addition, the polarimetric of SAR image also provide the visual of the geological structures as presented by the bottom right figure. This figure is an ALOS pulsar polarimetric image could identify lineament related to fault and circular features at the Patuha geothermal field. I think that's all my presentation. Thank you.
Yeah, I think we can move on to Fred on geothermal exploration using regional geologic model. Go ahead, Fred.
Yeah, thank you. So let me kick off with the observation that most, if not all, geothermal power plants in Indonesia are located in the central parts of the islands, close to volcanoes. And that seems logical, as below volcanoes, a lot of heat is stored in the Earth's crust. making it relatively easy to produce geothermal energy. But it becomes less logical when considering that most energy consumers live in large cities in coastal areas. And as a consequence, geothermal energy has to be transported over long distances, which is expensive and inefficient. So is there an alternative source of geothermal energy closer to the cities? And the answer is yes, it's sedimentary basins. In Europe, geothermal heat has been produced from sedimentary basins for already several decades. The heat is used for both industrial and societal applications. But exploiting geothermal energy from sedimentary basins is challenging. Basins typically contain many layers with highly deformed and different types of rock, as you can see on this example geological cross-section of the Paris Basin. And it's this geological complexity that makes it difficult to find the best location for the production of geothermal energy. This applies also to the sedimentary basins in Indonesia, like for instance the West Java Basin, as you can see here on the right. It's there actually even more difficult, mainly due to the lack of geological data. So exploring the Indonesian basins requires a collaborative approach, acquisition of more data, and the use of advanced geologic modeling tools. The added value of geological modeling is illustrated in a case study of the Ombilin Basin in central Sumatra. Our Indonesian master and PhD students Vishnu Santoso and Lukman Sutrisno constructed a 3D computer model that comprises the main geological features of the Ombilin Basin and underlying deep crustal layers. And as explained by the previous speakers, the satellite and remote sensing data make it possible to map in high detail the geological and geothermal features of the surface. In contrast, a little to nothing is known about the deeper parts of the basin and crust. And this results in a 3D model with increasingly less resolution and detail at larger depth. Employing advanced modeling methods, it was nevertheless possible to compute a detailed temperature distribution in the Ombilin Basin. The left figure is a map of the computed temperatures at a depth of 1,000 meters in the basin. The yellow and red colors on the map show the areas where the temperatures are more than 30 degrees hotter than in other parts of the basin. And these areas are therefore potentially good locations to drill for geothermal energy. The figure at the right is a vertical cross-section through the basin. And here the results indicate the presence of a zone with increased temperatures at a depth between 700 and 1500 meters. And this hot zone sits in a rock layer with good reservoir properties. So both figures illustrate how geologic modeling can support the geothermal exploration of sedimentary basins. So as demonstrated, geological modeling is a powerful method to predict temperature inside basins of various rock types and under different conditions. Particularly useful is its use for the analysis of the impact of rock properties that are not well understood. The four graphs show, for instance, how the temperature in a basin will change when there are different heat-producing minerals in the crust below the basin. So this research was done by another Indonesian master student, Vicky Rulian Satri. Even though geological modeling is a powerful tool, its usefulness depends strongly on the quality of the input data. And as we used to say, rubbish in is rubbish out. So good quality geological data is therefore of key importance to get good and reliable results. The orange area on this map of Indonesia show the location of major sedimentary basins. And as you can see, these are situated mostly in coastal areas of the main islands, which is where also the major cities are. So these sedimentary basins thus provide an ideal opportunity for a cost-efficient and sustainable production of geothermal energy close to the main sites of energy consumption. However, exploring the geothermal resource potential of these basins is challenging. It requires a collaborative effort, bringing together geological knowledge and modeling expertise from Indonesian and Dutch partners. Finally, high-quality geological data is critical to boost the exploration and development of geothermal energy from sedimentary basins. Thank you. Terima kasih.
Thank you, Fred. Maybe we can move on to the next speaker, Pak Yunus Daud from Universitas Indonesia. Go ahead, Pak Yunus.
Thank you, Mbak Tia. I'm Yunus Daud from University of Indonesia. After discussing remote sensing technology, geology, and geological computer modeling as previous presentation, now I'd like to present about geophysics to know deep subsurface information of the geothermal system. So what is geophysics? Geophysics is the non-invasive investigation of subsurface conditions in the earth through measuring, analyzing, and interpreting physical fields at the surface. Why using geophysics is an important question, because only means to obtain deep or subsurface structure other than drilling, and other low cost, quick, and cover large area easily if compared to drilling. Next, please. Okay, the objective of geothermal exploration using geophysical technology is to answer the following questions. Where is the center of reservoir? What is the boundary of reservoir? What is the depth of reservoir? Can major structural features be identified? Can outflow structure be recognized? Are there shallow or deeper structures? And the most important question is where to locate best drilling locations. These questions can be answered using geophysical technology such as magnetotelluric, time domain electromagnetic, gravity, magnetic, microearthquake, and ambient noise tomography. Next, please. This is geophysical data workflow for geothermal exploration, starting from raw data, and then following by applying advanced processing, then doing geophysical assessment to get conductive clay cap, boundary of reservoir, top of reservoir, analysis of geological structure and fracture or permeable zone, and the last result is geophysical model. These results then be integrated with geological and geochemical data to assess resource or geothermal resources and doing well targeting. Next, please. Okay, I have two examples to give you insight about this geophysical technology. First is 3D MT and microearthquake data for delineating reservoir boundary and geometry. As you can see at the left figure, you can see the clear boundary of the reservoir, we call prospect boundary, surrounded by red color. This is cap rock. And at the center of this figure is cross section. As you can see also, the top red color, this is clear picture of clay cap. And click please, click of conductor. This is actually top of reservoir, and you can see clear picture of reservoir for green color and blue color, and you can see at the right figure, you can see the black dots. This is micro earthquake data. As you can see, this is clustered below the clay cap. This is a reservoir. So this data support the MT data. So we have a good understanding of the clay cap and on the surface. Next, please. The second example I would like to present is 3D MT inversion for delineating hidden geothermal reservoir. Why hidden? Yeah, because only unimpressive hot spring at the northern part of the caldera, and there is other magmatic manifestation inside the caldera has no surface manifestation. So this is difficult to locate where to drill to get high temperature, high permeability, and neutral fluid. So we use geophysics to answer this difficult question for hidden geothermal reservoir. Next, please. Okay, this is the result of geophysics, and you can see at the center. Yeah, click, please. Click and click. Okay, this is area of well targeting. The last figure, next, please. Okay, click, please. Okay, this is empty data, and then this is the result, and there is click, please, up down. This is no surface manifestation. Click, please. Okay, and the last one, this is the result of the hidden reservoir, and we can see at this figure the up-dome shape of reservoir. And then we prove this reservoir using slim hole. Click, please. Okay, this is 2,000 meter depth slim hole, and the result. Next, please. This is the last. Okay, next, please. And we get information that the temperature at the depth of drilling is 280 degrees C and neutral fluid. You can click at the right bottom figure. This is the result of our investigation in Eastern Java. So, okay, thank you very much for your attention.
Thank you very much, Pak Yunus. We are now in the last pitch from Professor Jan Diederik van Wees on de-risking exploration by integrating exploration know-how. And then afterwards, we will have a Q&A. And hopefully, Freek has joined us in the session. And the Q&A will be led by Freek. Go ahead, Freek. Jan Diederik, sorry.
Thank you, Tia. So I will talk about de-risking exploration. And this is a picture which shows the challenge for exploration that you want by making progressively more costs, first by surface exploration like remote sensing, but also geophysical techniques, and then later on progressively make more costs and do drilling, which was also shown by Pak Yunus, to show that and prove that the geothermal resource can be developed. So you make progressively more cost, and of course you want to earn that back after it's developed, but there is a large uncertainty whether it will indeed be successful. So what you do is to do this in a staged approach. And can I have the next slide? And this is showing this approach where you do indeed progressively more costs in the exploration, and then through appraisal by drilling wells, you prove the resource, and then you can make financial investment decisions to fully develop the resource by drilling multiple wells. And typically a large geothermal plant would take tens of wells to develop. And then after many years of production, then at some point you can reach the stage that you have to abandon. And when you want to understand both the full costs and the full earning, it's very valuable, very powerful to use a full techno-economic evaluation. And it also is very important to take into account all the underlying uncertainties, such that you understand the full risk, but also the full opportunities in the exploration. And what we also see when we analyze this jointly with the GEOCAP partners is that there is a very important interaction, well, both with government and funded campaigns and industry, because especially in the initial stages, to prove the reservoir, the risks are too high, and it helps a lot if government can step in. The other aspect is that in this process that there's a lot of interaction related also in the economic aspects of developing resources with government stakeholders. Can I have the next slide? So and this is also based off what we observe in the oil and gas industry, if we are faced with uncertainties, it's typically human to try to reduce these uncertainties as quickly as possible to a single conceptual model. And what we see, especially in multidisciplinary development, like in geothermal as well, it's a very technically very complex and challenging environment to develop geothermal, which involves both geologists, engineers, economists to develop such resources. And when you communicate across these uncertainties, it's typically reduced to simple one conceptual model, which reduces the full complexity of the uncertainty, but also the decision space is typically reduced to just a few alternatives. And with modern decision approaches and computer approaches, which allows you to take into account full uncertainty, you can reach much better decisions. And one of the things we developed in, can I have the next slide? In GeoCap is to develop actually a rather simple but powerful Excel tool, which allows you to take look over all these brick walls, integrating the different disciplines, going from exploration to the full development, and evaluate the effect of different uncertainties in your net present value, so your final income, where the red colors here indicate what we call the downside, so the situations where you don't earn any money, but so that you only make costs and you cannot recover these costs. And the other thing you can do when you do stochastic simulations is to understand the underlying parameters which cause you either these downsides or upsides. And what you typically see in this such analysis, and it's shown in this right hand top figure, is this is a mix of economic factors such as the completion of development, how much time that takes, but also in particular geological factors. And these geological factors you can steer then subsequently your exploration campaign, as shown, for example, by Yunus, how this helps, and also the other speakers, which reduces then your uncertainty and try to move the spectrum towards the upside after adding this information. And can I have the next slide? But you can also take a step back for things which are more generic, like, well, if you ask the questions like, what's the importance and controlling role of large-scale fault structures, such as the Sumatra fault zone in Sumatra, which is a very large tectonic feature, on geothermal resources. And this has been one of the reasons why a GeoCap PhD student, Lukman Sutrisno from Indonesia, is doing extensive research on this topic. The other aspect, can I have the next slide? And this is my final slide. As I mentioned, this interaction with government funding programs, especially in the pre-competitive stage, is very important. It also adds to the generic value of understanding underlying concepts for geothermal resources. And this is actually a picture from the Netherlands, which demonstrates also the importance, which I did not mention yet, the importance of harnessing surface data in a pre-competitive approach. And in the Netherlands, we compiled all the existing data we have from past oil and gas activities for geothermal purposes, and this led to a success rate of 90% of drilled geothermal wells in the Netherlands. And the other aspect related to that is that you can also identify from the generic correlations in the subsurface that it makes sense to develop not projects standalone, but in conjunction to prove or disprove certain explorative concepts. And that's my final slide. And I would like to thank you and hand over to Freek.
Thank you very much. I hope you can all see and hear me. Sorry for being a bit late. Thanks to all the speakers for great presentations. Very nice. we have a few minutes for some questions and answers. I have one question for all the panelists. I think the focus is very much today on energy production. I think there's also a lot of potential in geothermal for direct use applications. From the combined Dutch-Indonesian perspective, maybe on Diederik, you can share some things about direct use potential in Indonesia.
Yes, as was also shown by Fred Beekman, there's from Sedimentary, sorry, I should say frame this differently. We have in the Netherlands a lot of experience with direct use applications for geothermal, very successful. Of course, it depends very much on the proximity of heat demand, direct use applications. And of course, in the Netherlands, we use it mostly for heating purposes, like in winter time to heat households, but also greenhouses. But there, it's well known that also in other environments you can use this direct heat, for example, for cooling, so through absorption cooling, but also for many other agriculture or industrial processes.
Okay, thank you very much. I think we almost reached the end of this session. I would like to remind you that at 11 o'clock this morning, so that's 4 o'clock Indonesian time, there will be another session on for GEOCAP focusing on energy storage and grids, which I think is also a very relevant topic for geothermal exploration. In the chat, we've already listed our email and website addresses, so we're very keen to collaborate with you to develop the research agenda for geothermal energy, as we are convinced that geothermal energy is an important component in the total energy mix for both of our countries. So in fostering the energy transition, this is a very important component. Would like to thank once again the speakers, but also thank our sponsors that have made all this possible. And if there are no further comments, questions from the chat, Tia?
Yeah, well, we had one question, but I think Chris has already answered it in an elaborate way. And you can, of course, contact us through our website, www.geocap.nl, and also on the email address, which is written here, geocap-itc@d20.nl. I think if there's no any more questions, we can close our session. Thank you very much for everyone who attended our session. I think we give the floor to NWO again, to Winner Organization, because there will be another presentation from TU Delft. Thank you.
We give the floor to TU Delft. All right. Bye-bye.
Hi, everybody. Can you hear me? I'm Maren Bremer from TU Delft, and I'm not allowed to share my camera at the moment, but we are ready to present another talk, another small-scale project we just got granted this year. And I'm here together with our two PhD students, which is Anita Patricia. Hi, Anita, and also Lily Svalina. And we are happy to present the NEMO project today. Okay, I'm still not allowed to share my camera, I don't know, but I can share my screen. Who's actually the host of the session? Because I'm not allowed to share my screen as well.
Are you allowed to share a screen now? I think I've enabled you.
Thank you. Okay, so let me start. We will give a joint presentation today together with Anita and Lily. I'm Maren Bremer, and together with Gerline de Vries, we got granted a small-scale project called MISI Monitoring. It's a Dutch-Indonesian collaboration also on geothermal energy, and that's why we thought it fits well to present it also here. Thanks for the opportunity, also Tia and to the NWO. We have a specialty. We focus on two different sites in geothermal energy, which is the natural sciences and the social sciences, and that's why it makes it so exciting. We would like to foster scientific collaboration in the field of geothermal energy in Indonesia and the Netherlands. And also in the very beginning, I want to say that we are still searching for partners. So if you're interested, and if you're a company, a consultant, a researcher, a university, or a student, please feel free to contact us if you're interested to join this project. The aim is to build a long-term collaboration between Indonesia and the Netherlands, and we start from the very beginning. We are really looking for new partners here. The two main goals we have is a better assessment of the subsurface prior to drilling. So that's from the natural sciences perspective. So how can we develop techniques to better assess the resource, to also better characterize the reservoirs, and to also then in long-term monitor the production. And from the social sciences perspective, we try to understand how the public perceives geothermal energy in Indonesia. And Anita has a lot of experience on that and will explain a bit more on this. These are the people involved so far. So it's TU Delft, Uni of Twente, and at the Indonesian side, it's University Sriwijaya, and also State Islamic University in Raden Fatah in Palembang. We are happy to have them on board, but as I said, we are very happy to include you if you are interested. We have money to visit each other. So we have money to invite people from Indonesia to come to the Netherlands and see geothermal fields here, and to collaborate and discuss with us what we can do in the long term. The project runtime is actually for 1 year and started May this year, but it's already extended, and we have the offer to based on traveling and visiting each other. So we will also, as a Dutch consortium, then go to Indonesia and visit our partners there. Lily, I hand over to you to present the first results we have from former studies, and we will apply in our project here. Are you there, Lily?
Thank you. Because the host does not allow me to unmute, and thank you to allow me to unmute. So thank you, Marin, and also, ladies and gentlemen, thank you for sparing some time to allow me giving an update about the results of, it's actually a small part of my master thesis, and it's actually really related about the project that we're going to work on for the NEMO project. So here, what I want to share with you, with ladies and gentlemen here, it's about one of a fundamental approach that we implement for mission monitoring. It's called surface manifestation monitoring. This is actually like one of the important tools for us to understand about reservoir fluids as a result of like a geothermal utilization. And what we did here is basically we did an observation intensively about the chemical changes in the geothermal fields in the thermal springs at different year. Why we did this? Because it's gonna be like one of like a fundamental tool for us to capture a big reservoir changes that occur in our reservoir using like a simple capture by surface manifestations. And if you look here, like two of the figures on the left and also on the central here, what we can see, like some of the fluids changing right here to be more acidic and also to be more saline. And also this information bring a useful insight for the company that we collaborate with at a time, because this is what, like one of the important tool for us to understand about what's currently going on in the reservoir right now. But we look at it from the surface manifestations perspective. And what I believe is from this NEMO project is, of course, we want to do like an intense of the reservoir monitoring, but by using like implementation from the surface manifestations, it can be like one of significant tool for us to capture the insight from the subsurface of our reservoir in order to achieve a long-term of sustainability. Can you go for the next slide, please? Oh, okay, cool. Can you go one more time? Okay, cool. So we did not only do the quantification of the surface manifestations using hydrochemical perspective. What we did, it also we do the observation from the surface manifestations by looking at the physical changes in the surface manifestations around the system. And what we find here is we did the observations for some manifestations that around of the area, but on this case, I only show you, ladies and gentlemen, for a few cases. And what I can deliver to all of you that here, that using like a manifestations approaches, that we can understand about the current changes that occur right now in our reservoir system. For example, in M11 here, what we can see, like if we compare it to the temporary changes, the hydrothermal eruption currently intensively occurs these days compared to 2012, for example. It was not there, it was not accessed, but right now it was formed because of like many reasons. For example, like intensive fracture permeability, and also it can be induced by some of the reservoir exploitation. For example, like we involve about the dryness analysis and so forth and so on. And it can be like one of a important bridge for us to understand the system in a whole by using the surface manifestations. Can you go for next, please? Yeah, next one. Okay, cool. So thank you. Not only from one spot that we did the observation, but also we did another observation, for example, from M10, also from M2, and also the other observations, which for sure can also support the interpretations. And the message behind this is, I can say, like using this useful implementation from the surface manifestation in analysis, it can help us to understand about the system and also about the changes that are taking place as a result of exploitation. Because we believe that using like a regular monitoring from the surface manifestations, we believe that most of the manifestations are right here, especially for Indonesia, are surrounded in the locals, and also it sometimes can influence the local activities. And therefore, by doing like a regular monitoring of the surface manifestation as one of like a thing that we are going to do in the NEMO project, is going to be very useful for us and also for the companies and also for the partners that we collaborate with us, in order to give like more information about more insights from the system. And also it's going to be very important for us and unexpected changes. Can you go for next, please? Okay, cool. So the other thing that we implement as well in the my master thesis, and also maybe it's gonna be involved in the NEMO project. It's for sure we were involving XRD analysis, because it's gonna be very important for us to give like intensive interpretation, because in the geothermal so far we do not involve the fluids, but also we are going to involve the rocks as a result of the fluid rock interaction. We did the XRD in order to confirm our interpretation that maybe the aggressivity of the fluids that we found in the system from the previous interpretation is related about the mineral alterations. And also shows us that some of the good connection here, that on the right of the table here, we see like the linear correlation between salinity and also the acidity that occurs in the reservoir. And also it can influence us that, oh, many of the alterations that exist in the acid environment occurring in the environment. And also we're gonna open for any people, any partners that want to collaborate with us. We can open for any more discussions. We can open more any techniques in order to increase the understanding to attain the long-term sustainability project in the NEMO project this time. So for the next, I'm going to hand over to my colleagues, Anita, to explain from the social perspective, and time is yours.
Okay. Okay. Yeah, thank you very much, Maren and Lily, for the chance. Hello, everybody. Good morning and good afternoon. I'm Anita, also from TU Delft. Today, I'm going to give some overview for the social perspective of geothermal energy development in Indonesia. So if we talk about the potential of geothermal energy in Indonesia, as you know that Indonesia is located on the Ring of Fire beside the risk of the location. Indonesia then also has the potential of supply of geothermal energy in Indonesia. So about 40% of the supply, world supply of geothermal energy is located in Indonesia. And this potential, of course, makes Indonesia has a chance to be the prospective leader in the future, of course, if it is maximally explored. But however, if you see the graph there, I quote the graph from the Asia Biomass Office 2019. It shows there that from the potential of 27.8 gigawatt that Indonesia has, only about 1.2 gigawatt has been explored. So it's about 4.3%. Some technical problem already explained by Maren and also Lily, but beside the technical problem, we also face financial and legal barriers. And also the social barriers like public resistance, which can also delay the implementation of geothermal energy in Indonesia. What makes the social barriers or the public resistance occurs mostly in Indonesia? Can you go to the next slide, please? Okay. I did some literature analysis, preliminary literature analysis on this kind of research. Public reaction is divided into two kinds of reaction. Either the public accept the plan to develop geothermal in their region, or they resist the development of geothermal energy. And that reaction is actually influenced by the perception. So when the public has negative perception towards the geothermal energy in their development, of course, they will, in the long run, will resist the plan to develop geothermal energy in their region. From the preliminary literature analysis that I did before, the things that influence the perception of public is from the direct experiences and also the framing. The direct experiences mean that the public directly experience the situation where the project has been explored in the region, and the framing is how geothermal energy is framed, either by direct framing, it is by the related actors, how the related actors frame geothermal energy in the region to the local people especially, and also through media framing. It either can be by social media or by newspapers or other medias. I did the preliminary analysis also on the media framing. So how media in Indonesia frames geothermal energy. The analysis, I did the analysis on 316 articles. It is from Kompas.com and Republika Online. These two online newspaper is the online leading newspaper in Indonesia. And what was the result of the analysis? Can you next? Okay, So here is the result of the analysis that I did on the 2 leading online newspaper in Indonesia, about 316 articles that I already analyzed. Here is the mapping of frames. So there are 6 dominant frames appear on the media. They are energy and security, economy frames, politics and law frames, environmental frames, knowledge and information frames, and also social frames. And those are, I also already listed the common set of arguments raised in the media, and also the number of how many that frames appear on the media. And when you also see on the pie chart presented there, those are the distribution of the media frames. The most dominant frames appear on the media, how media actually frames geothermal energy is on the energy and security. If you see the set of the arguments there, the most dominant frames appear or raised in the media is mostly on the importance of exploring geothermal energy for the needs of the country, because Indonesia, of course, needs a lot of resources of energy to support the access of the electricity for the whole people in Indonesia. And the least frames raised in the media is social frames. This one is very interesting because when I did the analysis, social frames is actually something that is really close to the life of local people. But how media frames geothermal energy in the media, social frames is the least. So this one is very interesting, and also this one is something that we will dig further through the project of project. So we really looking forward your contribution also, if you would like to work together with us to talk or discuss about this situation. I give the floor back to Maren to talk further about this. Thank you.
Okay, thank you, Anita. Thank you, Lily, for sharing this presentation. And thank you, everybody, for joining our presentation. As we all 3 already said, we are happy to discuss further opportunities. It's a quite new project. We couldn't start yet because of travel restrictions. So we are happy to have your input and to have your interest discuss further. Either now, I don't know if there's time, or somewhere in the future, just contact us. Thank you. So I'm happy to take questions either in the chat or here, but or just drop me an email in the future.
Okay, thank you, Maren. Then I think we've reached the end of this session.
Okay,
thank you all for joining. Very interesting presentations and speakers. And we have a last video that we would like to show you. So please stay for a few minutes to watch the video. Thank you very much. Bye-bye.